Hello guys and gals. Today we're going to be starting the video a little bit differently. We're going to talk about these two questions and try to review what we already know. So for these two questions, we're going to think back to the last couple videos on how we solved exponential equations, or equations where x is in the exponent. Okay, so remember when we solved these a couple videos ago, we always had our perfect roots chart out so that we could get into a common base. So when we solved these, like for number 1, we solved getting each one of them to a common base. Well, 2 can't be a different base because that's as simplified as it goes. But let's see if we can get 32 to have a base of 2. I know that 32 is 2 raised to the 5th power times 2x minus 1, because when we raise a power to a power, we multiply. So now that I have a common base, just like the last video, we're going to set the exponents equal to each other. So x plus 1 is equal to 5 times 2x minus 1. Distribute that 5, so we get 10x minus 5 is equal to x plus 1 minus x, add 5, add 5, so that cancels. We get 1 plus 5 is 6 is equal to 9x, divide by 9, and we get x is equal to 6/9, or if we take a 3 out of both, that's going to be 2/3. Okay, let's try number 2 doing the same thing. Well, 4, I know 4 can be rewritten as 2 to the 2nd power, 2 times x in the exponent. And so now let's try to write 24, excuse me, as a base of 2 with a power of what? Well, 2 to the 3rd is 8, 2 to the 4th is 16, and 2 to the 5th is 32. So we skipped 24 somehow between that, because 2 to the 3rd was 8, 2 to the 4th was 16, and 2 to the 5th was 32. So we skipped 24 in between there. Well, maybe I could try rewriting 24 as a common base of 4. So leaving 4 to the x and trying 4 to some power to get to 24. Well, 4 squared is 16. 4 to the 3rd is 64. So today's video, you guys, is how to solve when we can't have common bases. So for example number 2, we don't have any common bases to solve. So today's video is going to be figuring out how do we solve these equations when we don't get it into common bases. Okay, so you're going to need a calculator, specifically a scientific one, or a graphing one if you have one, and notes. There should be a log foldable that goes with this. Our answer to that previous question on the previous slide is logarithms. So we're going to have to start with what is a log, and we have to figure out all the notation that goes with a log, because in math, when we learn something new, we want to talk about how we talk about it, which would be notation itself. Okay, so logarithms or logs. So today we're going to talk about what a log is and what it does for me. Okay, so this should be the front of your foldable. So logarithms are just a special way to ask a specific question. Well, first, this is the generic form of a log, and how we read this is log base b of a is equal to x. Log base b of a. Okay, and the question that the log answers is this: what exponent is required to go from a base of b to reach a value of a? So what exponent is required to go from a base of b to reach a value of a? So maybe this will make a little more sense for you guys if we convert logarithmic form into exponential form. So exponential form, we know, is base raised to some exponent equal to a value. Or you could say b raised to the x power is going to equal a, right? We've talked about graphing exponential functions, and our most generic function was b to the x, okay? So when we switch it to logarithmic form, what's happening is we're saying log base b of a is going to give me or solve for the exponent. So if I know the base value and the solution, if I know the base value and the solution, a log finds this exponent for me. So that's what the question is that we're answering with logs, okay? And how we read that again is log base b of a is x or is equal to x. So that's how you should read it in your head when you see these equations, okay? Okay, you guys, so we have two goals for today. We want to calculate the value of the logs, which is the left-hand side of your foldable. And on the right-hand side of your foldable, our goal is going to be converting between the two forms, just like we did on the front. Okay, so on the left-hand side, number one, log base 4 of 64 is equal to what? That's what we're trying to solve. So if we think about what the question is for a log, we're saying 4 raised to what power gives me 64? And if I look on my perfect roots chart, I know that 4 raised to the third power gets me to 64. So my log of base 4 of 64 is equal to the value of 3. It's the same thing. Okay, moving on to the right, we have 6 raised to what power gets me back to 216. Well, if I look at my perfect roots chart, I know 6 raised to the third power gets me to 216. And then moving on to log base 4 of 16, we're saying 4 raised to what power gets me to 16? Well, we either know that right off the top of our head, or we can double check with our perfect roots chart and know that it's 4 squared, or 4 raised to the second power gets me to 16. Because remember on the front of our foldable, that question that says what exponent is required to go from 4 to 16, or 4 to 64, or 6 to 216. Okay, you guys, this next one, log base 3 of 1 divided by 243. That one's kind of funky. We're trying to say 3 raised to what power gets me to 1 over 243. Well, because it's a fraction, I know that my exponent's going to be negative, and now I have to figure out what value, what number gets me from 3 to 243. And if we look at my perfect roots chart, that's 5. So because it was reciprocated, or because the 243 went to the denominator, we know that my exponent had to be a negative 5, okay? Okay, you guys, we've done 4 examples now, and if you've been confused on all 4 of these examples and you're not necessarily following with the question of what a log solves for us, there's like a shortcut in your calculator. And in this little box, I'm going to write this formula that's called the change of base formula, and it's like a shortcut, okay? So in order to calculate the following logarithms, you could use this shortcut. Log base b of a is equal to log of a divided by log of b. So I'll show you how to do the next couple. Okay, so what I mean when I say this is a shortcut, you, instead of thinking about this and using your perfect roots chart, you could grab your calculator and find on your calculator the log button, find the log button, punch in log of 125, and divide it by log of 5. If you punch that into your calculator, it'll spit back a number of 3. That's another way that you can solve these, you guys. Instead of trying to think about the power that gets us to the answer, you could just punch all of these in as log of 125 divided by log of 5. Okay, so if you need help with finding the log button on your calculator, or if you don't have a log button on your calculator, please ask me when we get back to class, okay? It's called the change of base formula. So you always take the number that is actually typed larger divided by the log of the base, or the tiny scripted number. So for this next one, it'd be log 4 divided by log 2. What does that value get me back actually? 2 when we punch it into our calculator. Okay, and so let's do another one. If we have log 7, because we take it this one divided by the tiny scripted one, okay, over log of 343, we get back in our calculator a decimal 0.33333 repeating, which I know is also the fraction 1/3. Okay. Okay, I'm going to leave the last 3 for you to solve on your own. So these 3 in purple that I circled or boxed, try on your own, and then we'll check them when we get back to class, okay? Alrighty, converting between exponential and logarithmic form. I'm going to teach you guys some more shortcuts. So on the front of the foldable, we talked about what exponential form looks like, which is, I'll write it in green, b to the x, which is equal to a. And then logarithmic, that's exponential form. And then logarithmic form, which I'll draw in blue, was log base b of a is equal to x. Okay, so we have to go between the two forms. So if we look at 1/5 raised to the x power is equal to y, we have to convert that to look like the log because it's currently in exponential form. Okay, my Algebra 2 teacher taught me this and it was absolutely genius, okay? So if we want to go from exponential to logarithmic form, what I'm going to do is she always drew an L. She said start with 1/5, connect to the y, bring it back up and connect to the x to make your L. So that's the order in which you know that you're going to write log base 1/5 of y is equal to that exponent, okay? Or you know that 1/5 is the base, so it has to be the subscripted b, and we know that logs solve for the exponent, and in this case it's x, okay? But the shortcut is to draw that little L so you know that it's log base 1/5 of y is equal to x, okay? And the shortcut that my Algebra 2 teacher taught me in high school, when you want to go from logarithmic form to exponential form, start with the base and draw an e. When you draw that e to go to exponential form, you see that you're going to get u to the v is equal to 15 divided by 16, okay? So those are like little shortcuts or tricks, if you will. So let's try another one. So we're going to convert 9 to the y equal to x into logarithmic form. So that means I'm going to have log base 9 of x equal to y. And then if I go down, if I keep going down in this column, let's try it again. I'm going to have log base 6 of x is equal to y. So now I'm going to have log base 6 of x is equal to y. Okay, let's try another one. Log base b of 123 is equal to a. So log base b of 123 is equal to a. And then I want you to try these two on your own, okay? And now let's move to the other column. So we want to go from logarithmic form to exponential form. So start at the base, draw a scripted e. So we have 7/4 all getting raised to the y equal to x. Let's do the next one. Start at the u, draw an e. We have u to the negative 16 is going to be equal to v. Try another one. We're going to get v to the 4th is equal to u. Okay, try these 4 on your own. So you're going to have 7 problems of your own to try, okay? and then we will check them when you get back to class. And please, 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 if you have questions with your calculator, let me know. Okay, what if we have to evaluate something that looks like this, like log of 100? There's no base, right? There's no subscripted base. So how do I do that in my calculator? Originally, if I had like a subscripted, oh, I don't know, like 5 or something, I would take log of 100 divided by log of 5. But now there's no base. So what does that mean for me? Honestly, it's not that big of a deal. If there's no base present in the log expression or equation, we assume that the base is 10. And this is also referred to as the common log, okay? So when you see log of 100, it's actually log base 10 of 100. So it's assumed to be a 10. And you guys, your calculator button is always in the common log. So that's why your calculator button just says log and it doesn't have a base necessarily. It's because it is in base 10, okay? All right, so what are the big things that we have to remember when we come to class next time? We gotta use, when I use my calculator, I'm using the change of base formula, which is log base b of a. That's the form that we've been given to calculate, right? And I'm going to rewrite it as log of a because that's the number that's written larger, like it's a larger font, all over the smaller font, which is log base b. So the value over the base, okay? And if I want to change forms, so if I have b to the x is equal to a, when I want to change forms, or if I want to take this exponential equation and put it into a log, I'm going to draw a big L, so it's log base b of a is equal to x. And if I have a log base b of a equal to x, and I want to convert it to exponential form, right? Exponential form, I'm going to start with the base and draw an e. So it's going to be b to the x is equal to a. So that's how we get, that's the shortcut of how we get between the two forms, or if we're converting from exponential to logarithmic form, okay? All right, ladies and gentlemen, that is all that I have for you today. So make sure you get all of these notes written down in your notebook, and make sure you remember the big takeaways that we just talked about on the previous slide in order to finish those 7 problems that you need for next class. So that's all, folks. See ya.